Hey guys, this is section 11.3, simplifying rational expressions. So we just finished up chapter 8, which did a lot of factoring, and we're going to use factoring within this whole chapter 11 that we're going to do. So it's not going to go away. Let's look at this first example. So it says find excluded values. State the excluded values for each rational expression. So first of all, rational means, or there's like a shorter word, ratio, within the word rational, which means it's a fraction. So you're going to see, we're going to be simplifying fractions here today, and then we're going to multiply them and divide them later on in the week. But in order to get the excluded values, you have to factor the denominator and set each factor to 0 and solve. So the denominator is the bottom part of the fraction. We could care less really what the numerator is on these types of questions. So right now we're going to focus on the bottom of this first example A and factor it. So this is negative 8. R squared minus 36 is a difference of squares from the last chapter, which factors into R minus 6 and R plus 6. Okay. And with that said, we know that the denominator cannot be 0. So the numerator can be anything at once. I usually write no because the n over o, and 0 represents the denominator, and you can't have that. So we need to figure out what two values for r make the denominator turn into 0. So for this one, if r was a 6, then the bottom is 0. So r cannot be a 6 from that one, and it can't be a negative 6 from this one. Otherwise, the bottom would be 0. So these are our excluded values, 6 and negative 6. So you can try example 1A, which is very similar to that. 1B, we're going to factor the denominator, so n squared stays up top. Now we have a trinomial at the bottom. If you need to go off to the side and make an x, we want numbers that multiply to a negative 5 that add up to a 4. So factors of c that add to b. We just finished that again. Those two numbers would be a 1 and a 5, and the negative needs to go with the 1 to add to a 4. So this is going to be n minus 1 and n plus 5. And again, we look at the denominator and think what values of n would make this turn into 0, and that would be a 1, so n cannot be 1. And from this one, n cannot be a negative 5. So it's only all about the denominator. Factor it first, then figure out what values would turn it into 0. So you're going to try 1A and 1B on that slide, and we'll talk about it in class. The real-world examples of using rational expressions. So this is talking about find the height of a cylinder that has a volume of 821 cubic inches and a radius of 7 inches, round to the nearest tenth. So the little study tip bubble says the volume of a cylinder is given by this equation. So we're going to have to use that. Volume equals pi r squared, h. The height of the cylinder is h, the volume is v, the radius is r. So they're basically saying we can use this one and set it equal to h because we want to find the height. So you're like kind of dividing by pi r squared. So we can use volume divided by pi r squared equals h when we calculate the height. So we know the volume is 821, so that goes in for v. For pi, we can use the pi sign, or 3.14. The radius is 7, and we have to square that. And that's going to equal our height. Now, if you carefully type that in the calculator as a fraction, exactly as you see it, you'll get 5.3 inches rounded to the 10th. So that is the height of the cylinder. So you're going to try number 2, but be careful, it's talking about the diameter of 18 inches. So you need to think of one extra step before you jump into the formula there. Moving on, these are just the exponent property rules going back to chapter 7. So you try both of these. It's just kind of review. In Delta Math, we're going to ask for a code word, and that code word is kitten. Every time you do this, meaning crossing off the x squareds on top and bottom, it's going to kill a poor innocent little cat. So if you have things at the top and the bottom that are separated with addition signs, you cannot just cross off the x squareds and think this is 2x plus 1 over 3. And the reason why is, think about it with numbers. So if I have 4 plus 5 plus 6 over 4 plus 1, if I look at this, the top right now, 4 plus 5 is 9, plus 6 is 15, 4 plus 1 at the bottom is a 5, and this should equal 3. Now if I think it's okay to cross out the 4s, now I have 11 over 1, and that is not the same thing as 3. If we look when we have factors, so 4 times 5 times 6 over 4 times 1, so the bottom would be 4, 4 times 5 is 20, times 6 is 120, this is equal to a 30, and since they're all multiplying, I can cross away the 4s, and this would be 30 over 1. So, moral of the story is you're allowed to cancel out common factors on the top and the bottom of a fraction when they're multiplying, not when they're adding. So when we do this next part, I can't just cross off like these two n's, or I can't cross off these two y's, all right? That is not allowed. So we're going to simplify this rational expression. The steps are listed in the box here. First, we're going to factor the numerator and denominator. Find the excluded values. So again, that's when you set the denominator equal to 0. And then we'll look for any common factors that will divide out. So at the top, 2r plus 18, that has a GCF of a 2. So you can bring out a 2, and it's 2 times r plus 9. On the bottom, two numbers that multiply to a negative 9 that add to 8. This factors into r minus 1 and r plus 9. So I factored, step 1 is done. Next I need to find excluded values. So that again comes from the bottom. What two numbers can r not equal? R cannot equal a 1 from the first group, and r cannot equal a negative 9 from the second. So there's our two excluded values. Step 3 then is to simplify. So looking at this numerator and denominator, common factors can divide out. So the r plus 9 and the r plus 9 divide out, and this simplifies to 2 over r minus 1. So simplifying is done. So you please try 4a and 4b. Again, factor everything first, state the excluded values for the denominator, look for common factors that cancel out, and then simplify. And lastly, we need to find the zeros. Okay, we have some steps off to the side. Again, step 1 is to factor everything we can. Then we're going to actually simplify and set the numerator equal to 0. So the top simplifies to two factors. Two numbers that multiply to a negative 18 that add to 3, and that's negative 3 and positive 6. So I factored, check. Simplifying is next. So I see x minus 3's. Think of this one as in parentheses, and these can cross away. So this simplifies to x plus 6. And since that was our numerator, we're going to set that equal to 0 and solve it. So this is a baby 1 step where you subtract 6. So x equals negative 6. This would be the 0. So this is when the y value is 0. So again, you can try both of these, factor everything, simplify, and then set the numerator equal to 0 on this one.